Okay, lesson 2, we're going to analyze curves again. This time, instead of just figuring out where they're increasing or decreasing, we're going to figure out where they're concave up or down. So you have to understand kind of what concave up and down is. So shape like that is concave up, and this is concave down. So on this shape particular, you can see that from here to here that this is concave down, and then at this particular point you can see that the shape changes to concave up. So now we're going to be looking for this point. Where is it changing? So it's called an inflection point. Okay, so we're going to also keep going on what we were learning before. So we're going to find the critical points, figure out min-max, intervals of increasing, decreasing. Then we're also going to do the inflection point and figure out where it's concave up or down. Okay, so y prime, our slope, 3x squared plus 6x minus 24. I want to know where that equals 0. Factor. Okay, so now on my number line, -4 and 2, what's happening with our slope? Okay, so I'm going to plug in something like -6, negative makes positive, 0 makes negative, something like 5 makes positive. Okay, so we are increasing, max, decreasing, min, back to increasing. Okay, so we know increasing, we are increasing from -infinity to -4, and then we're going to increase again 2 to infinity. We are decreasing between -4 and 2. We have a max at -4 comma something, and we have a min at 2 comma something. So now you need to plug those values in up here. Okay, so while you're doing that algebraically, I'm just going to actually be typing this on my calculator. Is this the one we just did yesterday? Or different? Okay. So -4, when you plug it in, you should get 80. And 2 plugged in, it's -28. Okay, so now we're also going to figure out this inflection point. So how are we going to do that? We are now going to take the derivative of the derivative. So we're going to call it y prime prime. So this equation, we're going to derive it. So 6x plus 6. So this is called the double derivative. So y prime prime. So where does it equal 0? So I'm going to factor. So at x equals -1. Okay, so I'm going to also draw a number line. And this is analyzing y prime prime. So if I plug in a -2, this would be negative. And if I plug in a, let's say 0, this is positive. So it's concave down in this zone because it's negative. So negative y prime prime is concave down. So from -infinity to -1, and it's going to be concave up from -1 to infinity. Okay, so we also have to know the point of inflection. Point of inflection is -1 comma, and again this -1 you actually have to go back up to the top again to plug it in because it's a point, you want to know the y value. So 26. So if I'm going to draw this, okay, 1, 2, 3, 4. Okay, so actually I do know that the y-intercept is 0. So I'm just plugging in 0 here. You're going to get 0, 0. Okay, negative 1, 26. So I'm not going to provide a y scale. I'm just trying to give you a basic idea. So that's there. This is up at 80. And here we're down. Okay, so it's going to go up, hit a max, point of inflection, min, and then back up. Okay, so can you physically see that this is concave down? And then here we're switching our graph. And then from here on, we're concave up. Okay, same thing. Okay, so we're going to derive. So we get x cubed minus 9x squared. So where does that equal 0? So I'm going to factor. Okay, so at x equals 0 and x equals 9. Okay, so plug in something like negative 2. Negative 2 squared is positive. Negative 2 minus 9 is negative, so that's negative. Plug in something like a 4. 4 squared is positive. 4 minus 9 is negative. Plug in something like a 10. Positive, positive. Okay, so it's decreasing from negative infinity to 0. And then it's obviously going to have some kind of flatten. And then it's also going to start decreasing again. So you can see that this is different, that we have a back-to-back interval of decreasing. And then it's increasing from 9 to infinity. Okay, we know that. Let's just get our points and we'll analyze what they are later. So 0, comma, when you plug in a 0, you get 0. 9, comma, and then we'll plug in a 9. So while you're doing that algebraically, I am going to enter this so that we can see it. So oh, it's a big one. Didn't leave enough room. Okay, so now let's do our concavity. So y prime prime. So if I derive this, 3x squared minus 18x, where is it 0? So I'm going to factor, take out a 3x, take out a 3x. So at x equals 0 and x equals 6. Again, on the number line, now I'm analyzing this. So negative put into here, so let's go negative 2. So negative, negative makes positive. And plug in like a 2 makes positive, negative. Plug in like a 10, positive, positive. Okay, so we're concave up, negative infinity to 0, and then from 6 to infinity, and we're concave down between 0 and 6. Okay, I'm just going to write the points out, 0, 0, and 6, negative 324. Okay, let's graph this. So we have 0, 0, 6, negative 324, 9, comma, negative 547, or 4, yeah, 7-ish. What else do we have? 0, 0, I think that was it, right? Okay, so here's what it looks like. We are, first of all, decreasing, and then we flatten, and then we decrease again. Slope of 0, and then we decrease. Okay, and then once we get to 9, we start increasing again. So that's what it looks like. Okay, so decreasing, flatten, decreasing. And once we get to 9, we start increasing again. Okay, so technically this would be our min, and we wouldn't even have a max point, and then we would have points of inflection. So you can see here, concave, this shape is concave up, and then right here, now my shape is concave down. And then here you can see that I switch and I'm concave up again.